Let us see one more problem based on basic proportionality theorem and its converse.
Please subscribe and don't forget to click the bell icon for the more updates.
Let us see what the theorem is, what the problem is. See here, ABCD is a given quadrilateral, PQRS are the points of trisection. See, it is to be underlined here. These are the points of trisections for the given sides. Okay, of the sides AB, BC, CD and DA respectively. Next. And are adjacent to A and C. C. Are adjacent to A and C. This is A. Okay, A and C. These are adjacent to A and C. Like this. Okay. These 2 points are adjacent to C and these 2 points are adjacent to A. Like that it is given. And we need to show that what? Prove that PQRS is a parallelogram. That means the quadrilateral which is formed inside is a parallelogram that we need to show. Understand? So here this is a parallelogram. How to show that? Simple. Again take the help of converse part of the basic proportionality theorem. Just simple thing it is. And take the triangle ADC. Triangle ADC. See, I am drawing here separately. ADC. So this is A, and this is D, and this is C. Right? And as we said that here S and R are the points of trisections. Okay, S and R are the points of trisection. What is meant by point of trisection? Let me explain you very simply. I'll tell you very simply. Understand? So here points of trisection means a point, okay, which will do the on making line segment into 3 equal parts. Okay, then a point which divides the line in the ratio either 1:2 or 2:1 is called point of trisection. That means when a line segment is made into 3 equal parts, okay, that point is dividing, okay, either 1 part is to 2 parts or 2 parts is to 1 part. Such an existing point is called point of trisection, and here R and S are the points of trisections of AD and DC respectively. So what can we say here? If this is a long distance, okay. So since it is long distance, if it is if it is x, this would be how much? 2x. Why? Because x plus 2x will be 3x. So we made this total line into 3 parts. Okay, the line which is divided into, we don't need to consider x also. 2:1. The line which is dividing in the ratio what? 2:1. So here P, we can write that dr is to RC in triangle. Let me write here. This is the proof of that. I am writing here proof. Okay, in triangle ADC. In triangle ADC, right? Okay, since these are points of trisections, we can take a dr by RC equal to what? 2:1 or not, because this is lengthy and this is short one. As R is a point of trisection, it will be a point which divides the line segment in the ratio 2:1. So therefore dr by RC equal to 2:1. So dr by RC equal to 2:1. Okay, 2/1. Next. Here, this is also a point of trisection. S is also a point of trisection of AD, no? So what can we say here? DS by AS is equal to what? 2:1. So tell me, this ratio is equal to 2:1 and this ratio also is 2:1. So from these two results combining, what can we say? dr by RC equal to ds by AS or not? Exactly. dr by RC equal to ds by AS. dr by RC equal to ds by AS. Let this be condition 1. So dr by RC equal to ds by AS. So we said, see, come to converse part of basic proportionality theorem. What can we say here? This is triangle DAC. In this we said that ds by AS, see here, ds by AS equal to dr by rc, means ds by as equal to dr by rc, means this rs line is dividing these two lines dc and da in proportionately or in equal ratio, is dividing in equal ratio. That means according to converse part of the basic proportionality theorem or Thales theorem, we can say that the line which divides the two sides of a triangle in equal ratio will be parallel to its third side. That means what? Here this will be parallel to this. Got it or not? So from this, okay, we can write implies we can write what? SR is parallel to AC. SR is parallel to AC, right? So this is the first result we got. Okay, now just see. Okay, this is one of the result we obtained by with the help of what? With the help of converse part of the basic proportionality theorem. Let me write here converse of basic proportionality theorem. Okay, from the converse of basic proportionality theorem we could show this. Right. One more thing I want to say. Just see this. SR is parallel to AC we got here. Similarly, consider the next triangle. What is the another triangle? You can form a sorry. You can consider the another triangle which is on other side of AC. What is other side of AC is there? Tell me. See here, this is AC. Okay, on this side of AC we have a triangle ADC. On the other side of triangle is AC. Sorry. On the other side of AC, the triangle is ABC. Understood? In this triangle ABC, again, if you are going to apply apply the points of trisection, not applying. I'm sorry. Okay. So in triangle ABC, we said that P and Q are points of trisections. Okay. So points of trisection means, let me draw here separately the figure. This is B. This one, I have drawn this figure separately, right? Okay, anyways, B, this is A and this is C. BAC. Now, as we said that Q is a point of trisection over here and P is a point of trisection over here. Okay, so now, what can we say here? Since Q is point of trisection of BC, okay, in this triangle, again what can we say? In triangle, okay, in triangle BAC or ABC. What can we say here? Since P is a point of trisection of AB, we can write PA by PB equal to what? 2:1, because point of trisection means the point which divides the given line segment in the ratio 2:1 or else 1:2. This is here like this, so therefore this is two parts and this can be one part. Okay, so now here PB by PA equal to what? 2:1. Similarly, since it is a point of trisection, now again we said that Q is also a point of trisection of BC. So what can we say here? BQ by QC is also what? 2:1. So BQ by QC is also what? 2:1 or not? Exactly. So from these two relations, what can we say? This PB by PA is also equal to 2:1 and this BQ by QC is also equal to 2:1. That means these two ratios are again equal because the values of them are equal. So here from this implies we can say that PB by PA will be equal to what? BQ by QC. BQ by QC. So from this condition, what can we say? Again, can we apply? See here, join the line PQ. Then this PQ line is dividing the two sides of the triangle in equal ratio or not? In the equal ratio, means proportionately. So here PB by PA means PB by PA equal to BQ by QC, right? BQ by QC. That means this PQ line is dividing BC and AB in equal ratio, so therefore, okay, this is here we can clearly apply converse part of the Thales theorem. How it is applicable, can you tell me? Yes, here when one line divides the two sides of a triangle proportionately or in the equal ratio, then that line will be parallel to third side. That means what? Here this line is parallel to this side. Third side is this one only, no? So therefore what can we say here? PQ is parallel to, here PQ is parallel to what? AC. So this implies PQ is parallel to AC. Right? So this is some another conditions we obtained. Another condition we obtained here. Right? Okay. So two conditions we obtained here. Now just to do one small analysis. Here we said that, just see, let this be condition 1. This is also from Converse of Basic Proportionality Theorem, and this is also from Converse of Basic Proportionality Theorem. In this condition 1, we got SR parallel to AC, and this is PQ parallel to AC. SR is parallel to AC, and this is PQ is parallel to AC. From this, what can you say? Okay, SR is parallel to AC and PQ is parallel to AC means what? SR is parallel to PQ or not? See, I am telling you, L is parallel to N and M is parallel to N. That means these three lines are parallel together or not? Or else you can say L is also parallel to N. Okay, similarly, here SR is parallel to what? AC, and SR is parallel to, which one? Sorry, SR is parallel to AC and AC is parallel to PQ. So therefore PQ and SR. Okay, let this be condition 1 and this is condition 2. So from this, what can we write? Okay, from 1 and 2. Sorry, from 1 and 2. From 1 and 2, what can we say here? Here SR is parallel to AC and PQ is parallel to AC. So therefore, SR is parallel to PQ. SR is parallel to PQ. Yes. That means this PQ and this SR are parallel to each other. Let me draw this quadrilateral which is formed inside like this separately. So this is P, this is Q, this is R, this is S, and we proved that PQ and SR are parallel together. So these two are parallel to each other. Okay, this is parallel to this. Okay, now imagine I just want to draw. If I draw similarly, I want to write similarly here. Similarly, if you take diagonal BD, means BD, consider BD with the same reason, can you prove that RQ is parallel to PS or not? Same analysis we can do here also, like as this before. Okay, with the same analysis we can prove that okay, QR is parallel to PS. Okay, so we can write here similarly with the help of what? This is consider BD. Similarly, if you consider BD, okay, in this BD, then if you do the same process, then we can prove. We can get PS is parallel to QR. PS is parallel to QR. So let this condition be another one. So here SR is parallel to PQ we got. Okay. And here PS is parallel to QR also we can get if you draw the BD and you do the same process again. So that means what? These two sides are also parallel. Now my question is that in a quadrilateral, if two pairs are opposite sides are parallel to each other, this pair is also parallel, then this pair is also parallel, then that quadrilateral is known to be a parallelogram. That means this PQRS quadrilateral which is formed inside by points of trisections of the given sides of the quadrilateral is again a parallelogram. Is a parallelogram of that. Okay, so we can say that PQRS is a parallelogram. Parallelogram. Right? So that is what we need to prove. Once again, I am going to explain you because it may be a bit confusing. So let me explain to you once again. Here we took a first triangle. In that triangle, we took the condition that R and S are the points of trisection. So therefore, on simplifying the given conditions, we got dr by RC equal to ds by AS. When dr by RC equal to ds by AS, what can we say? This SR line is dividing the two sides of this ADC triangle proportionately. So therefore, this line is parallel to AC. Right? Parallel to AC. The next one. Here also we took another triangle ABC. This triangle we took. Okay. And here we also know that P and Q are also the points of trisections. Okay. Depending on that condition, okay, we obtained again what? PB by PA equal to BQ by QC. Okay, PB by PA equal to BQ by QC. Okay, that means what? Here in this triangle ABC, okay, this PQ also dividing the sides AB and BC in equal ratio. That means what? Proportionately. So therefore, this PQ again will be parallel to AC. That also we got here. Let this condition be 1 and this condition be 2. Combining these two conditions, okay, this AC is parallel to SR, AC is also parallel to PQ. So therefore, AC is commonly parallel to PQ and SR. So therefore, SR and PQ are also parallel. So from this, what did you obtain? Like this, these two sides are parallel. Means these two sides are parallel. Got it? Now, same experiment, same process if you continue with the diagonal BD. If you draw BD and separate the triangle BDC and ABD, okay, from that what can you obtain? From that you can obtain that PS is again parallel to QR, same as before. Understood? So now these two also became parallel. So that means here these two are parallel and these two are already we got parallel. Now in a quadrilateral, if two pairs of opposite sides are parallel to each other, means this pair is also parallel and this pair is also parallel. If both the pairs of opposite sides are parallel to each other, then the quadrilateral is said to be, okay, a parallelogram. Got it? So like this we can prove, and here we proved this theorem or proved this result using converse of Thales theorem. This is what the usage of converse part and Thales theorem, right?
Please subscribe and don't forget to click the bell icon for the more updates.